guys and welcome to my channel. Today in this lecture I am going to teach you how to solve a problems using Newton's forward interpolation formula and the Newton's backward interpolation formula. So here is some technique how to solve the Newton's forward difference tables and the Newton's backward difference tables. Here we have given x and f, and in place of x we have x naught, x1, x2, x3, and similarly we have in place of f we have f naught, f1, f2 and f3. So in the first difference what we'll do here, first we'll take these two elements. So taking these two, we'll write here f1 minus f naught and we'll assume it as a. Similarly for these two we can write here f2 minus f1 means f2 minus f1 equals to b, and for f2 and f3 you can write f3 minus f2 equals to c. And now in the second difference we will take here b minus a, and we will assume it as x, and for these two b and c we can write here c minus b and we will assume it as y. Similarly in the third difference we can write here y minus x equals to z. Here in the formula of Newton's forward interpolations we will write del f, and the Newton's backward interpolations we will use inverted del f. So here we have the general formula to calculate the Newton's forward interpolations. We have P and S equals to F naught plus S del F naught plus S into S minus 1 upon 2 factorial into del square F naught plus S into S minus 1 into S minus 2 upon 3 factorial into del cube F naught. And here we have F naught, and this represents the del F naught, and we have del square F naught, and we have del cube F naught. So in place of F naught we have F naught, and in place of del F naught we have a, and in place of del square F naught we have x, and in place of del cube F naught we have z. And similarly we have for Newton's backward interpolation formula P and S equals to F4 plus S del F4 plus S plus 1 del square F4 upon 2 factorial plus S into S plus 1 S plus 2 upon 3 factorials and del cube F4. And here in the Newton's forward interpolation we have a spacing is given by S is equals to x minus x naught upon s, and here s represents the spacing. So in Newton's forward we will subtract x minus x naught, since we have the x naught here first element, and in the Newton's backward interpolation we have s is equals to x minus x3, since we have the last element x3, so we'll write here x3 upon h, and here h represents the spacings. So here we have a problems. Estimate the value of log 3.5 using Newton's forward difference formula as well as Newton's backward difference formula. Here we have given x and log. So in place of x we have 1, 2, 3, 4, and we have the log value given here. So here first we need to calculate the Newton's forward and Newton's backward difference tables. So we have x and f. So in place of x we have 1, 2, 3, 4, and in place of here we can write here 0 and 0.6931, 0.6931, and in the same way 1.0986 and 1.3863. So in the first difference here in the form this represents the forward and this represents the backward. So in the first taking these two elements, so we can write 0.693 minus 0, we get 0.6931, and for these two elements we can write 1.0986 minus 0.6931. By subtracting we get 0.4055. Similarly 1.3863 minus 1.0986, we get here 0.2877. And in the second difference taking these two elements we get 0.4055 minus 0.6931, we get the negative value here means minus 0.2876. And for these two elements we can write 0.2877 minus 0.4055, again we get the negative value means minus 0.1178. And in the last we will subtract these again, so minus 0.1178 minus, and we have already minus, so we'll get plus means minus 0.1178 plus 0.2876. So by calculating we get here 0.1698. And here we have the formula for Newton's forward difference. We have the Newton's forward difference formula P3x equals to F naught plus S del F naught plus S into S minus 1 del square F naught upon 2 factorial plus S into S minus 1 S minus 2 and upon 3 factorial into del cube F naught. and here s is equals to x minus x naught upon s. Since we need to calculate the value at log 3.5, means in place of x we can write here 3.5. So in the space we have s is equals to x minus x naught upon s. We have in place of x we can write 3.5 minus x naught. Since we have the x naught 1, this value we have x naught 1, so in place of x naught we have 1 minus a spacing. Since we 2 minus 1 1, 3 minus 1 1, 4 minus 3 we get the 1, means there is a spacing of 1. So in place of yes we can write here 1. So by calculating we get the yes is equals to 2.5. And now here this is f naught, and this represents the del f naught, and this represents the del square f naught, and finally this is del cube f naught. So in place of f naught we have 0, so we'll write 0, and in place of yes we have calculated 2.5, and del f naught we have 0.6931. So 2.5 into 0.6931 plus yes we have 2.5. Similarly we'll put these all values and calculate. So after calculating we get here 1.2465625. So finally we have the value of log 3.5 equals to 1.2465625. Now again we'll solve this using using Newton's backward difference formula. Here we have then using Newton's backward formula we have P3s is equals to, since we have the last term here, we have the last term f3, means f naught, f1, f2 and f3. So let here f3 plus s del f3 plus s into s plus 1 upon 2 factorials. We'll write here inverted del. So we have f3, and we spacing is given by s is equals to x minus x3 upon s. So we in place of x we have 3.5, and in place of x3 we have x naught, x1, x2 and x3 equals to 4. So we get 3.5 minus 4, and we have the spacing 1, so we get minus 0.5. So we have f3 plus s into inverted del f3 plus s into s plus 1 by 2 factorial into del square f3 plus s into s plus 1 s plus 2 upon 3 factorial into inverted del cube f3. So in place of f3 we'll write here f3 and del f3, and again we have del square f3, and finally we have del cube f3. So here we have 3 1.3863. So in place of f3 we have 1.3863 plus we have s equals to minus 0.5. So minus 0.5 into we have del f3. So you'll write here 0.2877 for backward formula, 0.2877 plus again we have minus 0.5. In place of s we have minus 0.5. So minus 0.5 into s, so minus 0.5 plus 1 upon 2 factorial, and we have del square f. So del square f equal to minus 0.1178. So in this way, substituting these all values and by calculating we get here finally 1.24652. So in this way you can calculate the, or we can solve the problems using Newton's forward formula and the Newton's backward formula. Thank you for watching the video.